Okay, so we're going to continue where we left off, and we've got an f of x is 5x squared minus 1. G of x is the square root of 5x plus 5. F composed with g of x, which means I put all of that square root of 5x plus 5 into the 5x squared minus 1. So there it is. I put g of x into f of x. And then when we square root, we know it lifts the radical. So we have 5 parentheses 5x plus 5 minus 1, distribute, and there's your answer. Okay. Now what if I did it the other way, g composed with f of x? So I'm going to put the 5x squared minus 1 in under the radical. So I have 5 parentheses 5x squared minus 1 equals 5. 25x squared minus 5 plus 5. And square root of 25x squared is 5. And the reason they use the absolute value of x is, remember, when you square root an x squared, it can be plus or minus. So instead of writing plus or minus, they write the absolute value of x. Okay? All right, so now we're going to compose with a number, f composed with g of 9. Well, the first thing you do is do g of 9, okay, which is 2 times 9 minus 8, or 10. And then you put that number into f. So I put 3 over 10 minus 4, which is 3 over 6, or 1/2. So take the number and just kind of go backwards. 9 first goes into g, get an answer. Then that answer goes into f. So work from right to left when you've got a number and you want to evaluate what that does with that function. So g composed with f of 6. So first I put 6 into f, and I get 3/2, and then I take the 3/2 and put it into g, and you get -5. All right, so find the composition in the domain of the composed function. Well, we look at f of x first, and then so it can't be -2. Okay, so, well, that's just talking about the domain. But when we compose it, we put 3x plus 2 in for the x in the f of x function, evaluate it, simplify it, and get 1 over x. Well, from the composed function, we know that x cannot be 0. But it also can't be -2, because with just the f of x function, it can't be -2. Okay, so there's 2 things we have to leave out of the domain, and that is, so we go -infinity to -2, -2, 0, 0 to infinity. So that's the way you're going to leave 2 numbers out. You're going to have 2 union symbols. Okay, but you have to look at the original functions, and you have to look at the composed function to determine what the domain can and can't be. Okay, so it says find 2 functions f and g such that h of x equals f composed with g of x. This is difficult, and I will not put this on a test. You may have a couple on the homework. But if g of x is 3x plus 7, and f of x is the square root of x, then when we compose, put g of x into f of x, then we have the composed function. Okay, and you just have to, this is almost by inspection is what you have to do that, which means you have to kind of just look at it and figure it out. I don't like that, because I like things I can actually figure out rather than just kind of look at them. All right, so here we have, we want the 2 functions that would make x plus 1 cubed plus 8. Okay. So one of them is going to probably be that what's in the parentheses, x plus 1, and the other one would be x cubed plus 8. So when we put g into x, g into f, we'll get x plus 1 cubed plus 8. So those are your 2 functions. This says estimate the function values from the graph. F minus g of 3, so you look at 3, and remember that's your x value, so at x equals 3, So if I'm looking at this, I go here, 1, 2, 3, and we got a point here and a point here on our graph. Okay, so F is the blue. So F of 3 is 4, and G of 3 is 3. So when we evaluate that, then we're going to have 4 minus 3, which is 1. Okay. G divided by F at negative 2. So again, we're going to look at the graph, and we go negative 2, and we have a point here, and we have a point way down here. So F is blue, and so we have the G value is a negative 4. So negative 4 divided by positive 2 are your two numbers, and that's going to give you negative 2. So F composed with G of 1. So these are a little more difficult. So first we look at, remember we look at F first. So you're going to look at F of 1. So if I go here at 1, the blue line is at 2. So F of 1 is 2. Then you're going to go to 2 and look at your G function. So the answer is going to be 4. Okay. So put F of 1 into G. F of 1 is 2. G of 2 is 4. F composed with G of negative 3. So again, G of negative 3. So here G is the red line. So at negative 3, we're at negative 4. Then you're going to go to negative 4 for F, and you're going to be right there at negative 2. Okay. F composed with F of negative 3. So F of negative 3, 1, 2, 3 is 0, but then I'm going to put 0 into F, and I'll be up here at 2. Okay. And so I don't think I have any of these on there. So I believe this is as far as we're going to go with this. Yes. Okay, so there's part 2. I'm sorry I got interrupted and cut it off early.